This is less of an update video and more of a current state of things video. Unfortunately, the game hasn't come as far as I'd like in the last few months. Development has slowed down to a crawl, but here's what I have. I've ditched the idea of making tracks with Blender in favour of making them with the Spline tool instead. This gives me the distinct advantage of being able to change and alter the level without jumping in and out of Blender, saving me a lot of time and headaches. But the Spline utility functions are the real key feature here, both for creating the geometry for the track and handling aspects of the player's physics. I've also reverted back to the original plan of moving the player down the track at a mostly constant speed, and only giving the player left and right movement. The turning is handled automatically based on the spline data. Gravity, which is relative to the player, is also set via the spline data, specifically the spline's normal at the point the player is closest to. I'll go into more detail about the player's handling later on. Another thing that I've added is the ability to add objects to the track and have them use the track's rotation. It works by placing the object based on the 0 to 1 normalized time of the spline, and then, using the spline utility functions, rotating the object to better match the track's surface, with an adjustable offset for fine-tuning. It should help prevent some of the awkward, ill-fitting positioning you saw in the demo I put out last year. I also swapped out the main character for a non-VRM model, which means I can use the correct lighting type. The model isn't mine, I downloaded it, but I did have to rig it myself. It's still a placeholder model, but it's a bit closer to what I'm looking for. That's the gist of everything that's changed, which brings me on to the next subject. While experimenting with track design, I was making loops and corkscrews and noticing that there wasn't enough geometry for various bends, which was leading to some very rough traversal through these areas. A secondary point is that I was looking to create pipe sections on the track, full pipes, half pipes, etc. Specifically, I wanted corners to have sloped sections on the outside edge. Now, my idea for this involved transforming the geometry into these specific shapes. But to do that, I would need more geometry, as in more polys. But I only needed them in key specific areas. So my solution was to place empty game objects that served as markers for the start and end point of these sections, and from there, subdivide the mesh and then manipulate the positions as needed. Furthermore, the Blender track I had previously had awful topology, which was the byproduct of me trying to smooth out the surface. So if I do my own subdivision, I need to be aware of the problems in that regard. Long story short, it hasn't worked out all that well. Let me elaborate. Let me start at the absolute beginning of how I got to this point. I started looking into how to build a mesh along a spline, and that led me to a video by Game Dev Guide called How to Build Roads Procedurally in Unity with the Splines package. I more or less copied his code and process to build a basic track for the player to be on. After experimenting with track length, bends, loops, and so on, I came to the conclusion that I needed more geometry, or rather, more geometry in specific parts. One of the things that bothered me about the implementation from the video was that the resolution of the track was uniform, even if straight. Flat sections of the spline didn't need that much resolution. I made a diagram about how I wanted it to work where the corners would get more polys both along the length and to the sides, while the straight parts got a few quads along the length, but decided against it as I was still getting to grips with the code I had just nicked. But I still needed more polys for the corners. This led to my idea for subdividing the mesh. I make some empty game objects that I use to mark on the track where I need more polys. Then in my code, when generating the mesh, once I reach the point where those sections are, I start subdividing, adding more vertices between the left and right sides of the track. It keeps adding them until I hit a maximum value. Once the section is over, it starts removing vertices until it goes back to normal. To do this, I set up an array that contains information about how many additional points need to be added between the left and right vertices. It increases the number or decreases it when it enters or exits the section I marked out. The code that does all this is terrible, but functional. But it was infuriating trying to get it to work. But the solution itself is still pretty awful. Following that, the next logical step is to build triangles. And this was not fun. Unity requires triangles to be set up in a counterclockwise fashion, otherwise you'll end up with holes. I spent quite a while trying to figure out what the order of the vertices should be in, but I also had to keep in mind that when not subdivided, each bit of the mesh that was going along the track was just a quad, made up of 4 verts and 2 triangles. After subdivision, it ended up becoming 2 quads next to each other, and then again and again after that. This led to some problems ordering wise. I thought I could handle each quad as I went down and across, but that ended up not working, and there were a number of holes in the mesh. So instead of doing each quad for the subdivided parts, I ended up doing 2 quads each time, which led to correct ordering, and then it worked out. Now by this point the code was not a mess of for loops, but I still had UVs to do, which was a challenge unto itself. Going back to the borrowed code from that video, for the UVs they're applying an offset that uses the distance between the left and right side verts and the vert directly in front of it for their respective sides. This helps repeat the texture along the path of the spline without any weird warping, maintaining the shape of the texture along the length. Unfortunately, I struggled to replicate the results of the subdivided mesh, leading to some very strange looking textures, and although I got semi-close to it working at points, it was still misaligned. With all that said, I need to make a confession. I did not have a clue how UVs worked in Unity at this point, so I really failed to understand why I couldn't get it to work. So I did some research and found a video from our Lord and Saviour Brackies that explained how UVs worked. They use a 0 to 1 value for the X and Y axis of an image, and that's how it's mapped to the texture. I know this makes me sound like a complete and utter amateur, but I haven't manually created a mesh since my university days, partly because I never had to, so I had to relearn a lot of this. Anyway, following this new information I did the following. For the back leftmost vert, I set the UV to 0, 0, and for the back rightmost vert, 1, 0. As for all the verts in between, I divided the distance between the left and right verts by the number of additional verts I had put there to give me an incremental distance. So each point in between, I just added those to the x-axis. However, I got rid of the offset, so now the front left and right points would have 1 on their y-axis. This does mean that the texture is no longer horribly warped, but it no longer maintains the correct shape. But I find the result to be acceptable for the time being. At this point I now have a track with extra vertices in places where I think I need them, and it all renders mostly correctly. The next step? Modifying the geometry to get slopes out of those corners. Remember how I said the code was a mess at this point? Well, it was the kind of mess that made getting sloped sides near impossible. The script I use has so many bloody arrays, and for the sides I made another one that stored the vertical offset I was adding to raise them. But the problem was that I could only add it to the sides, not the points in between. Trying to modify the points in between would be excessively complex. I would have to figure out a way of gradually increasing or decreasing the point's vertical value, but with the way I calculate which way is up, it would require information about the surrounding points. Information that does not exist at the points in the code I am trying to calculate it. So the best I managed was to have slightly raised edges to the track. On the plus side, they did at least work, but everything up to this point was just a mistake and the wrong way of trying to solve this problem. Since doing all that, I've had some time to come up with some revisions to the idea. I have absolutely no idea how well they'll work, but I'll try and explain them anyway. Instead of trying to transform the geometry that's there, I think I might be able to append a slope to the side instead, adding it on instead of trying to manipulate what's there. There is still a problem with how to define those corner regions, but I think I might be able to define sections based on the knots in the spline. I'll get back to that point in a bit. As for tunnels, half pipes and so on, I think I might have to create those as separate meshes. I'm not sure if I'll make these using the spline tool still, or make them using Blender and try to snap them together in pieces. It might also be possible to use ProBuilder to build some of that. For track generation itself, well, while I was brushing my teeth some nights ago, I had an epiphany. Remember that diagram I showed you earlier? Where the straight was a single quad and the corner had a lot more? It's a simplification of the issue, but I think I might know how to handle it. Splines in Unity are made up of knots. These knots can be defined as a Bezier knot or a linear knot. The former provides more of a curved line and the latter is more straight. My point is that if it is straight, I don't need as high of a resolution for it. So instead of defining these sections based on empty objects placed on the track, I should define these sections via the knot type instead. Again, I don't know how well this will work, but it sounds better than what I'm currently doing. And instead of inserting verts between the left and rightmost sides, I want to change it so it sets those extra verts at the same time it's sampling it, hopefully getting rid of all those arrays of garbage in the process. But I also need to be able to increase the resolution along the length of the section as well, which I can probably do based on the knot data, looking ahead and seeing if I need more or less resolution depending on if I'm approaching a curved knot or a linear knot. As for the UVs, I will need to go back to using the offset for the y-axis of the UV to preserve the texture's proportions. But I understand the problem better now, so it shouldn't be too difficult. The x-axis side of things can remain the same. Just before I move on to player handling, I want to talk about corkscrews. Oddly, the subdivision method I have does provide a smoother surface than not having it, although more control over the resolution along its length would also help. Unfortunately, there's a more severe problem. The player was bouncing and not sticking to the surface of the track correctly, often rolling over. I suspect it's something to do with gravity. I'm currently setting the player's gravity to be the up vector of the spline at the closest point to the player. I need to do more testing on this to see if I'm correct, but if I am, I will need to find an alternative solution. And this finally brings me to player handling. In the beginning, the player's handling was a physics-based system where the physics engine was pushing the board off the ground. It was believable but difficult to control, and it couldn't really be used on anything other than a flat surface. I changed it to a different solution where it's just a board model attached to a capsule collider as a parent, with a sine wave imitating the motion of the board pushing off the ground. The rotations of the board work similarly to the original, where I used the dampening functions of the mass library to have the board tilt on various axes and then return to the original position once the input is stopped. That said, it is a lot more extreme in the original version than in the new version. What's most annoying about this new version is that although it is more responsive now, the movement seems to lack the weight or reactivity to the geometry it's going over. It's not as bouncy either, which doesn't lend well to the believability of the hoverboard. Furthermore, now that I've made the player only move left or right, I'm starting to notice more how badly the new system feels to play. It just doesn't feel right. I've tried adjusting the camera and the board's animation dampening stuff to improve it, but even with that, it's still off. This puts me in quite a predicament. This is the third iteration of the player's handling, and this is after several tests with various different methods. However, this specific iteration was made under the assumption that I would be giving the player full control over where they were going and not reverting it back to the left and right movement, so perhaps it's just a matter of further tweaking. But on the off chance it isn't, I want to experiment with a PID driven system. That's a proportional integral derivative controller. I'm not even remotely qualified to explain how it works, nor do I have the time, but what I do have is the code. I actually did some experiments with this last year, very briefly, when trying to come up with solutions to get the player to turn towards waypoints, back when I was using that system. This was also back when I was using the physics-driven hoverboard. The results were not what I was looking for, so I ended up not using it then. But the situation is different now, so it might be time to dig out that code and try again. But before that, I want to nail down track creation. I need to know what kind of levels and terrain I can reasonably create, and then go about altering the handling until I can excel at any problem I throw at it. And once both of those problems are dealt with, the trick system will be next on the docket, which I haven't even really touched yet, but I do have a few rough ideas of how I want it to work. I'll save the details for another video, if I ever get to that point. Thanks for watching. I don't have too much else to add, but I would like to thank all the people that commented on my Godot video with their own thoughts and suggestions for improvements and other things to look at. I wasn't all that happy with the video, but you guys really cheered me up, so thank you. As always, check out my itch.io page for various things I work on, and come follow me on Twitch, where I do game dev streams among other things. And you can support me on Ko-fi if you want. All those links are down in the description. Don't forget to leave a like and a comment as well if you want. I hear the algorithm loves that, but I also like getting your feedback as well. And I'll see you next video.